On today's streaming audio, we're going to start with a buzzword and pick it apart to figure out what it really means. Our guest today is Ben Stopford, and we're talking about data meshes. What the heck are they? But before we start, let me tell you that the Streaming Audio podcast is brought to you by Confluent Developer, which is our site that teaches you everything about Kafka, from how to start it running and write your first app to architectural patterns, performance tuning and maintenance. Check it out at developer.confluent.io. And if you want to take one of our hands-on courses that you'll find there, you can easily get Kafka running using Confluent Cloud. If you sign up with the code podcast100, we'll give you an extra $100 of free credit to get you started, which at my exchange rate is about 74 quid, which ain't bad. And with that, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get started. Our guest today on Streaming Audio is Ben Stopford, who is the lead technologist at Confluent, the author of Designing Event-Driven Systems, and a colleague of mine. So it's nice to have you back on the show, Ben.
Great to be here, Chris.
Our topic on the table today is data mesh, which sounds like a bit of a buzzword, but I'm promised there's a hard meaning to it. I'm going to take us through it. Let's start with a definition. What is a data mesh?
That's a very good question. It is a set of principles, and you can use them to guide a certain type of architecture, which is really data architectures. And it's a little bit like microservices in that regard.
How so?
Well, in that it's a way of building a style of application. So much like you can use microservices, you can not use microservices. You can use a whole bunch of other, you use a 3-tier architecture, an N-tier architecture. You could just build like a, simple, dumb monolith if you want to. Often those are the right choice, right? So, monoliths, very valid pattern for building a system. Likewise, you might want to use a data mesh. So I guess a good way to think about a data mesh before we try and define it, because it's quite long-winded, is really in what it is not. So a data mesh is not your standard data architecture where you have a bunch of systems at the front and you have a big data warehouse at the back and all the data feeds into the data warehouse. That's kind of that's the pattern that it's getting, or we're trying to get away from. So in the microservices analogy, the data warehouse pattern is the monolith, right? So nothing wrong with monoliths, and there's nothing wrong with data warehouses. For certain use cases, they just come with a set of trade-offs. So for certain types of organization, you will potentially get some preferable properties if you take the data mesh approach. And basically, in a nutshell, if you think about a data warehouse approach, it's like lots and lots of systems at the front, and they're pointing to one big data warehouse at the back. In a data mesh, you've got this many-to-many relationship. So it's actually a lot more like services. So instead of having a service, you have a data product, which is a bit like a service that gives you data. So you've got like a bunch of data products around the organization, and they all provide self-service data. And if, let's say you're doing some kind of fraud detection, you have this kind of menu of different services. They're all the services, they're all the data products that they're all like providing historical data. It's all curated by the people that know that data. And you can basically just subscribe to those data sets. You can rewind, replay, get the data set maybe inside your database and do your fraud detection, or plug it into your application and do it in real time. So that's like the concept of a data mesh. It's just like data on demand directly from source, but where that source is lots of different places. And you are actually one of many consumers. So rather than the data warehouse where it's a bunch of applications going to one data warehouse, this is actually a bunch of source data products all feeding data to a bunch of other consuming data products. And there's effectively a kind of web of interactions. And you don't have to build these with event streams. Event streams are by far the most common way of doing it. I think it was the inception case was based for data mesh was based on event streams, as I understand it. But you have a So there are other approaches, but definitely the most common way of doing it is to use event streaming, because it actually obviously takes out all of that complexity of those many point-to-point connections that you would have otherwise, and just gives you streams of data on demand.
Okay. Let me risk missing the point in the hope that it helps clarify it. Imagine I've got a big data warehouse and it's a bunch of tables in a big whole relational database. And I wake up one morning and I put nearly every table in a separate database, right?
Right.
So now I've got a whole bunch of different databases, each serving up one set of data.
Right.
Have I got a data mesh now? Am I happier?
No, not. Well, you might call it a data mesh. It's a bit like microservices. Like, if I break my application up into lots of different bits, is that microservices? Or is microservices actually something?
Why am I breaking things up? How is it helping me? That's what I'm trying to get to.
Yeah, that's a good point. So, so this is actually probably where you do have to get the principles to come in. But the first two principles are effectively socio-technical. So they're about domain ownership. You should get counterparty information or customer information from the system that it originates it. That way, it's most likely not to be broken, basically.
So if there's a data feed team in my bank, I should be getting my data feed data from them, not from the data warehouse team.
Yeah, or the finance team that happen to be your mates and they've got the stuff and they'll give it to you. So, you don't want these kind of Chinese whispers or game of telephone, as they say, stateside, those kind of problems. But yeah, so that's the first one. The second one is data as a product. So that's very closely related in my mind to domain ownership. Like if you want the feeds team or whoever it might be to provide accurate data to the rest of the organization, one of the things they have to do is make sure that data is really consumable. So it's got to be of decent quality. It can't have, every 50th minute message has a random control character stuck in there for you to sort of make your system blow up, et cetera, et cetera. And that's really about making every system that curates data in any form and disseminates it to the organization feel responsible for that role. So it's like making it a primary role. And the best way to think about this is actually in the anti-pattern. So in the anti-pattern, you're a trading system. Maybe, you have like some trade data, which you give to the rest of the organization. That was some flat file feed that was written by a grad like 6 years ago. He's moved on. Nobody really knows how the code works. You could change it, but you're probably not going to unless you are absolutely made to do it. And it's just like you just don't really see it as part of your job so much. It's like your primary reason for existing is to be a trading system and help these traders, not to disseminate information to the organization. So data as a product is about sort of trying to rejig those priorities and say, look, being a data product in an organization these days is so important to the overall operation of the organization, to actually what the organization will spend on its data. It tends to be huge these days. So being able to disseminate from source high quality data is really advantageous. So that's kind of like, I think that sort of differentiates that from the data warehousing model, where you tend to do the cleansing inside the data warehouse. And then there tends to be, that's kind of one anti-pattern that you get out of it. So, sometimes the data warehousing team, maybe they don't really understand the data that well. Depends how complicated the data is. If it's really simple data, it might be all right. If it's really complicated, nuanced trade data or something, it's often a complete nightmare. But and then the second part is you don't have this single point of coupling where, data warehouses tend to end up with lots of different people trying to mash around, trying to get data out of this single data schema. So you as a user of the data don't have much control. And that's like a double-edged sword. It can be a good in some cases because you just go to the data warehouse and you don't have to worry about it too much. But it can be bad if you do actually want that extra level of control, which you often get in larger organizations. So it's sort of horses for courses. No model, pros and cons across those two. So those are the two. Those are the two core ones. There are another two principles as well, which make the whole thing work. So those two about I would call those the two foundational principles. won't talk about it.
Those two seem sort of like cultural, more about how you approach the problem rather than technology per se.
Yeah, they're these kind of. So I think the term is a term that is sometimes used is this sort of socio-technical concern. To say it's kind of a mix of social and technical elements, whereas the second two principles are pretty much like just technical things, effectively.
Okay.
So they're like data. That's just making them actually easier to explain as well. One is making data self-service. So really that means if I want to have all of the customer information, I need to be able to get access to it immediately. I don't have to ask anyone, I don't have to raise a request, or maybe I have to ask permission to see the data or something. But basically it's all automated for me and I can get the whole set, hold or access to the whole data set. And the second one is governance, which is a bit like adding unit testing in Agile. It's like you don't have to do it, but if you don't do it, you're probably going to make a mess of it. If you add it, you got a much better chance of succeeding.
Okay, so what is it? What's the governance piece?
Governance is actually, that's like you could do a whole podcast on that. But effectively, it's a number of tools which will help you in a actually often imperfect way, but they help you better manage data in the organization. So things that governance tools tend to do include answering questions like, how do I find this piece of data? Okay, there's a problem with this piece of data. Where did that data come from? Where did it, how can I trace it back to its original source?
Right.
So, is there is data different in different places? Can you resolve those kind of differences? So a lot of it's really about discovery of information and figuring out where information came from. Those are probably the two primary concerns. There's some other things we do with like master data management and stuff like that. But for me, those are the two that really make a big difference because they make effectively these data sets visible. So in a data mesh, in a data warehouse, you don't necessarily need these as much. They're still useful, but you don't need them as much. In a data mesh, because you've sort of got this web of interactions, suddenly your life's got much harder. It's a bit like in Agile. Like in Agile, because you're moving faster, you kind of need the testing. Like if you haven't got the testing, if you do like XP and forget to do testing, then you tend to make a mess because you're kind of moving really fast and you break a load of stuff and then you didn't know you broke it. So your software never works. Whereas if you've got the testing, you're probably okay. And it's sort of similar. It's a similar thing. I think if you build a data mesh, because of the sort of many different connections that you end up having, if you haven't got the governance, you're just much more likely to make a mess of things.
Is it part of like? I was thinking Agile, what you're really doing is tightening feedback loops and installing good feedback loops.
Yeah, exactly. Yeah.
And it's that kind of thing.
Is the governance part supposed to be self-service?
Well, let me. Yeah. So the self-service thing. The self-service thing is kind of helps with the feedback loop. But then you often need other pieces. It's like change management is another part of it, which sounds boring, but again, it's really important. Like if I want to change this field in a non-backwardly compatible way, how do I do it without it becoming some project I have to hire 5 people to go and execute on? Because we don't know who consumes the data and how we're going to notify them and ask them if it's okay, and are they actually going to change their side of things at any point in time soon? Is somebody going to chase that down? So just from a practical sense, there's just like an operation of a large, distributed data system, which is what a company ends up being. Doing that well is actually quite complicated, and you need like tools and processes to make that work well.
Yeah, that makes sense. You know what this reminds me of? It's like early days of the web, right? You have all these startups starting up, building their products. And a lot of them started to realize that if they wanted to grasp adoption and drive new use cases, they needed to make their API more than an afterthought, but actually a central part of what they're delivering to people.
Yeah.
The API is as important, if not more important, than the front end that the users use.
Yeah.
And is it fair to say it's that kind of driver, but within a large organization?
No, I think it's just that kind of driver for data is the way I describe it. It's exactly the same thing. I mean, what you're providing is an API for data you're saying that as a system that produces data, if you're disseminating that to the rest of the organization, then you are providing an API, and it's one of the most important things that it's one of the most important interfaces that you have, because arguably, your role of disseminating that data to the rest of the organization could actually become more important than whatever it is your system does. If you think about it holistically, maybe not just in terms of like what your boss thinks you should do, as it were, but in a sort of holistic organizational sense, often your role is more important in that regard.
And there must also be a kind of discovery piece if you want, say, ideally a department you haven't thought about will come and find your data and use it.
Yeah, absolutely.
In a new way that you hadn't thought about.
Yeah, matter of fact, you might not even know that they exist. Ideally, you won't even know that they exist. They just come and use the data, and you don't know anything about it because you're just providing good data, and lots of people use it.
So, is there an inherent kind of like a catalog idea or something? What is there anything about in data mesh that specifies discovery?
Yeah, absolutely. Yeah. So, I mean, that sort of sits under the governance piece. So if you build a data mesh using, Confluent technologies, Confluent Cloud is obviously the best place to do this. It has a bunch of features that make it kind of easy. It's got infinite storage, which means that you can do the self-service data. So you can cache data in Kafka. You don't have to do it that way. You can cache it in a database in each service if you like and have some kind of replay button. But the easiest way to do it is to cache it in Kafka, which will do in Confluent Cloud, which will do it efficiently and store that at low cost for you. And then you've got the discovery piece, which is what you asked about, which is covered by our kind of data governance features. So what those allow you to do, as sort of a concrete example, is you can basically have, if you use event streams to build a data mesh, the simplest approach is basically that the data each data product is represented as an event stream. It's just the simplest way to do it. So if I have customer data, I would have, a customer event stream in Confluent Cloud with infinite storage enabled. Well, it's enabled anyway, but you can store the whole data set inside there. And then you can provide that data to anyone that wants it. So how do they get hold of it? Well, you would tag that data, that topic, that event stream in Confluent Cloud as being, customer data. And then and you actually also might tag it with other things like, you might tag sub-elements, which is other data sets that it might contain, so like secondary dimensions. If you're tagging data in the cloud product, then you can do it with different dimensions, and you can also have a ability to search that really easily. You just put it into the search box and search away, and you will be able to find this tagged information. And then you can basically pull up like a lineage graph, which will show you like how that data flows inside the mesh. So you can see, for example, if it's recombined with something in a derivative data product. But the easiest way to do a data mesh is actually not to have derivative data products. You just have keep the architecture as simple as you can. It's like the law of Demeter.
With the primary sources.
Yeah, so it's like the law of Demeter for data. If you've ever come across the law of Demeter,
I can't remember it. Remind me.
It's the one where it's like don't chain calls. So like you don't have like foo.bar. Whatever, very long call chains, because it creates, if you have like a very long chain of like 8 different object calls, what you're really doing is creating a very tight coupling down to this method. You're better off with just having like fewer. And it's the same thing, it's back coupling, saying it's going to decouple things more if the fewer interconnections you have, the less coupling you have overall. And less complex that coupling is.
So I think we should pin down exactly how this relates to event streaming, because you've hinted at it. But is there something about event streaming that is well suited to data meshes, or something about data meshes that is well suited to event streaming? Or is this an any database, any architecture kind of approach?
No, I think there aren't that many ways to do a data mesh, and event streaming is definitely the primary one. No doubt about that. I mean, you've got a sort of many-to-many architecture, so you need the sort of primary functional principles that a data mesh has to provide is you need to be able to get access to a particular data set, but you also need to be able to mash that up with other data sets. And those will all by definition be in different parts of the organization because they'll be in different data products across the mesh. So the easiest way to do that is just subscribe to those event streams, pull them together into your database and join it there, or use a stream processor and join it in the stream processor, in which case you can then use that data directly to trigger an application to respond directly, or obviously you could put that in the database if you wanted to. But it tends to be, in the data mesh world, it tends to be more about collecting data sets together. And the reason it obviously is different there is to a data warehouse is that most of the consuming applications or consuming databases, the databases that are making use of other data sets in the mesh, they don't need all the data that the organization has. So they're not, they have like some small subset of data that they're actually interested in. And because the mesh provides them data on demand, they don't really have this, they don't feel like responsible for taking all of the data. So that point's kind of worth drilling into, I think, because it's kind of it's a little bit subtle. But if you think about it in the traditional world of flat file transfers or enterprise messaging, the first thing you do when you get hold of a bit of data is you write it down in a database because you might never see it again because it's sort of ephemeral. So you write it down and then you have to maintain that data set. So basically what happens is everyone builds up these big historical copies of data which they have to maintain over time, which is actually pretty tricky when schemas change and so forth. So it actually has a fair amount of cost to it. And then often that, there'll be a whole bunch of that data. Maybe you're interested in, I don't know, customer information, but really you only use the name and the ID. But you'll take all of the information because you may never see that information again. It'll be a pain to get it. Well, in a data mesh, you don't have that problem. It's quite easy to get hold of the data. You can always repopulate it. So, if you just need the customer name and the ID, you're just going to take the customer name and the ID, which actually saves you a lot of pain in the long run as data sets change and you have to manage the life set of that data and all that sort of stuff, the life cycle of that data and so forth.
Yeah. It reminds me of? We had Gerard Kleiss on the show a couple of weeks back talking about GraphQL.
Okay.
And how you can build up queries that just take the fields you need.
Yeah.
And as a supplier of that, you can be auditing which fields are actually in use and which fields matter to your users. So I can see that fitting in well.
Yeah, I mean, it's kind of it's kind of a similar concept. There isn't really, as it stands today, that there's no way that you can kind of audit that. It's a good product idea, though. Maybe we should build that, or somebody else out there should build that. I think that sounds
streaming audio, the podcast where we do product design before your eyes.
Go on, make your million, or build the open source product that's going to change the world.
Okay, so I can definitely see a synergy there. So, but just one last thing on the whole event streaming thing. Do you think it's tightly bound to the idea of real-time data streams?
Yeah, I mean,
does it help?
Yeah, I mean, you can really do it in batch. I mean, that's the self-service thing. I mean, self-service, if you've got to wait for the end of the day, I don't think that's really self-service. That's a bit like, you walk into McDonald's and you go up and you press the, thing and you say, I like my burger and so forth. And then you have to come back at dinner time. It's not really going to fly, is it? It's like, not if you're ordering a whatever, chicken McMuffin, whatever. What do they call them? Bacon.
It's been a while since you've been to McDonald's. Clearly.
Yeah, I haven't been to McDonald's for a while, it's true, but that's more to do with COVID, I think, than anything else.
Oh, that's fair. Okay, then. So you're in an organization, you decide that there are going to be advantages to setting up this mesh and taking responsibility for your feeds. How on earth do you get started if you're just McBank?
Yeah, that's a good question. So, I mean, firstly, you kind of work out whether or not you really want one. But I think you should always do that. You should always evaluate the pros and cons of these things, and you don't necessarily have to take all of it.
Yep.
But a great place to start is, obviously reading the materials that are available today. I know Zamak, who's the lady from ThoughtWorks who sort of proposed this set of principles. She's writing a book on it, which I've read a little bit of. It seems pretty good. We've also got some materials that we've written. Adam Bellmer, who's the guy who wrote the event-driven microservices book, he did a blog post recently on it. And that has a pretty cool demo, which lets you, or sort of gives you a sort of sample. It sits above Confluent Cloud. You can actually, it's running on a server on the internet, so you can literally just go and play with it. And that provides you with a kind of basis, sort of simplistic data mesh, and it demonstrates some of those kind of core principles. So in that, you can do things like you can pretend to be a source system and expose a data product as an event stream. You can look at the lineage of data. You can look at you can basically combine different data products together to create like a derivative data product using a stream processor, using KSQL, running on Confluent Cloud. And you can sort of manage data product lifecycle. And then obviously search, if you're tagging different data products, you can search all of those kind of things. So it provides a sort of wrapper over Confluent Cloud, has some additional functionality. And that's something that you can, it's all open source, so you can kind of take that, you can fork it, you can, if you can figure out the programming elements, then you can maybe skin it to your own organization and use that to sort of drive a project. But hopefully it gives you that like first step up. I think that's a really good starting point. And then, other than that, I think a lot of the materials that we're seeing are coming out. We also have a course on Confluent Developer. So if you haven't come across Confluent Developer, it's a fantastic resource for everything to do with event streaming. It's all free. It's got, I think, 9 courses on there. And a bunch of other things like cool resources, animations, event streaming, design patterns, and lots more stuff. So there's a course on there on data mesh, which goes through a lot of the principles, and it actually also has an exercise which uses this demo to allow you to actually, inside the exercise, you're building a little data mesh for your organization right there online in Confluent Cloud, which is pretty cool.
There is a hosted version of that demo if you just want to quickly go and kick the tires.
That's right, yeah. Yeah.
I've looked at that, and one thing I really liked about it is there's this idea of, okay, so you've talked about not being a derivative data product between organizations, right? You don't want this Demeter's law problem, right? But within your organization, there's nothing wrong with taking your raw data feeds and packaging them up for publishing.
Yeah.
So you might, if you're a price feed system, you might take the price feed stream and some analysis stream and publish them as one thing for the rest of the organization, right?
Yeah. Yeah, I think
so. You're sort of you're publishing your own complex queries for the sake of the organization.
Yeah, I think that's a pretty good way of a good approach to doing it. I think when I say in practice, data mesh is quite new. So when we say in practice, what we're really thinking of is systems which are data meshes or have a lot of the data meshes properties applied kind of retroactively, because the name's newer than a lot of the systems. But
first you get it working and then you name it, right?
Yeah, I mean, same with microservices, right? We were building microservices in like mid 2000s. We just didn't call them. We called them ThoughtWorks. We called them fine-grained SOA. That's what we were calling them. And it was a good 5 years before they became microservices. And when they became microservices, we'd also worked out that there were a few things you didn't want to do, like you didn't want to share a database because it causes lots of problems. We actually went through all those problems. And it's the same thing, I think, with data mesh. So, we've been building event streaming systems and actually messaging systems before that for a long time, and struggling with a lot of the difficulties that come from it. A lot of these principles like self-service data and data lineage and treating data as a product, these are things that we've explored. And the one that relates to the point that you were mentioning there, which is the derivative data products, the interesting trade-off here is this kind of like dumb pipe smart endpoints thing, or it's to put it another way, it's like the ESB approach. So again, this is all quite subjective, but if you, one of the problems that we saw with ESBs is they evolved to a position where they started to embed a lot of logic inside the ESB itself, which is very attractive, right? It's attractive from a software vendor perspective. It's attractive from the perspective of like a sort of pointy haired architect inside some big corporation. I'm going to control everything using this like validation rules inside, the central system. In practice, it actually makes it really hard to do stuff. And data mesh is trying to not do that, right? It's actually trying to say look, data should be freely available. So when we're talking about adding that kind of functionality, you want to be careful that it is the sort of event streaming stuff that we use to bind data sets together. That tends to be pretty simplistic. For example, it's joining on a primary key. It's like not too business centric. It's where if you did start applying like proper business logic into those data products, that's where you tend to have problems. And so anything that's like business specific, that really should be ideally owned at source or owned in a additional data product owned by that source domain. That's the typical approach.
Okay. You said something in there I can't let slide.
Sure.
Which was, in microservices, we found out that sharing a single database is a bad idea.
Yeah.
But why is it in a data mesh sharing a single Apache cluster would be okay? Or would it?
Yeah, I mean, can you build a data mesh with one cluster? Well, I think probably one of the really, this is a bit of an aside, but one of the really nice things about cloud, one of my favorite things about cloud is this idea of how many clusters you have kind of goes away, or certainly going away. So, right now you can create a cluster like instantaneously for nothing, basically, that's pay for use. And so, if in that model you actually think less about clusters, you just think about topics, and that topic could be in one cluster, it could be in another cluster. You kind of don't really care so much. And with things like cluster linking, which is a technology which joins these actual clusters together in a way that doesn't involve a proxy, so they're just like talking to each other, it actually makes that pretty efficient. So whilst there's still actually work to do that, there's notable move away from this idea of thinking in clusters and towards thinking just literally in like topics, and I can have as many of them as I want. That's really important, because if you think about another really important principle is this sort of data on the inside, data on the outside idea, which Pat Helland introduced really, really long time ago. It's like, I think the original paper was like early 2000s, but it basically it was written in the time of XML, but it was just saying that, data that you have in your database is very different to data that you share with someone else. And the reason is really simple. It's like, if you have data in your database, you can do whatever you want with it. It's like really easy. And if you share data with somebody else, suddenly it's like locked down and it's really hard to change. And that
means made a contract.
Yeah, the dynamic of that contract is really different. So that's why, and that is at the heart of your question. So if you go, I know it's been a while since your question, but I think your question was like, well, why don't I have this problem with microservices? Well, the reason is because you're wrapping them in an API, and the API constricts what you can do hugely, right? It's like hugely constricts what you can do and says, right, all you can do is like these various different methods. That's very, very different to exposing a database and saying, hey, look, there's my Postgres instance, off you go. That's like because a database has an amplifying contract. It has a declarative language which you use to talk to it, which actually amplifies the coupling to that thing. You can not only ask for the data inside that database, but you can ask for the data inside that database in all sorts of different ways, including maybe even creating your own data, right? It's an amplifying contract. Whereas a service provides a restrictive contract. It's taking, it's being very, very specific about what data sets and the protocol in which you're going to interact with that data. So even if it's a data service, they're two kind of very different extremes. The data mesh approach takes a third approach, which is to say, there is no protocol. You're just getting raw data. You can have all the data, and you can have that data updated live. It has a schema. You get it back in your database, so you have full control. And that's the crux of the whole thing. It's all about who has control over the data. And there's a tension in these systems between retaining control over your data on one side and making sure that it doesn't diverge or become like difficult to manage long term on the other side. And you're always balancing the trade-off between those two elements.
Right. So I'm finding a way as my department publishing some data to retain control over the shape of that data whilst also giving you a lot of freedom about what you do with it later.
Yeah. And you're doing that through a contract that looks a lot like an API, but it doesn't actually have really the interaction complexity. It's just actually a data stream. So a data stream is really a type of API where the contract of the API is really just the schema of the data stream.
Yeah. Okay. So this sort of leads to once you're in this place where you're streaming out data for other people to consume in their own ways, maybe you've made that organizational change. How do operations change when you're living in that kind of world?
Yeah, I mean, operationally, the nice thing about that approach is you have a huge amount of freedom. You can choose to be really simplistic. So you can treat a data mesh like a mechanism for getting batch data. If you want to, you'd have to kind of convert it. But you can literally you can do old school patterns and new world patterns, more contemporary patterns at the same time. But yeah, operationally, I think if you're just moving data between different data sets, I think it's actually pretty similar. The main problem is that you can't go out and buy a data mesh, and there's two reasons for that. One is, as we discussed earlier, a bunch of it's like socio-technical stuff, right? So you just can't buy that, period. Like you could buy some consultants, probably from ThoughtWorks, I guess, that would come in and tell you how to become data meshy. But you can't buy
2 packets of culture.
Yeah, well, genuinely, when I was at ThoughtWorks, we did go and people would go in and sell a block of Agile. It was kind of amazing, and that's a completely different story. But you do have this element of the socio-technical stuff, which you can't really do much about. But you do also need the technical part. And I said that Confluent Cloud is a great example of you can build a data mesh with Confluent Cloud. It has all the constituent parts, all of the parts of that meal, and what we're providing in those blog posts and so forth is a recipe that helps you kind of pull a lot of them together. But it's not like a shrink-wrapped data mesh product, and there would be a difference between those two things. Today, you still need to do a bit of work to piece these things together. We did some of that, I think, in that prototype application, which I think does a really good job of laying that foundation. But still today, it requires a certain amount of custom coding. Now, the reason that is not so bad is that generally what happens for most organizations is their mileage is going to vary a bit in some way. So, spending some time investigating allows you to, in building that layer on top lets you customize it to your specific requirements, because you're going to have, different data sets. You can have weird legacy systems, which are going to be harder to integrate. And whilst the nice, perfect picture that we paint and when we talk about these things looks very appealing and are very simple, just like with microservices, the reality is always much more messy. And as a result, you have to, it's the things that break the rules that tend to be the hardest parts to integrate, rather than the sort of happy path.
Mm. Do you think? I'm just wondering, like, the hardest part about shifting that is shifting culture. I think technology is hard to shift, but people are even harder. Right. So, what's the minimum you need? Do you need one? It feels like you need one department that says, I'm going to start publishing my data as a product.
Yeah.
And another department that's agreed to be the first people consuming it.
Yeah, I mean,
that feels like the bare minimum to get the ball rolling.
That's the bare minimum. You can sort of, ask another department and get the ball rolling like that. I actually think it has to be top down. I think that's the most successful route. Might not be trendy, but it's definitely the best way to do it. And that's actually cultural. So the data as a product one is the best example, right? So the data as a product thing, it is cultural. And, if I was going to give an organization advice on how to do this, it's like, you need to get your CEO standing up there in front of the organization and talking about data products and how important it is to be data centric. And this is what it means. And I don't know, make them go on training courses and so forth, whatever works for you. But, you do have to kind of get it into the culture in some way, because it is a cultural change. Maybe it's in your values or whatever, but those, that is probably the only way it's actually going to work in practice. And you sort of see this in, you see this in a bunch of different environments where, if you want a socio-technical property to work, maybe it's agility, maybe it's this type of approach to data, you kind of have to have that cultural shift that sits behind it.
Okay. Well, hopefully we've done a bit to lend the mindset that will help that adoption and shift.
Yeah, no, it's good. I mean, I think it's a final point I would add is that, one of the things I like about this is that is makes of whether or not data mesh is the perfect solution. I think that's still up for grabs. We haven't decided that yet. It's still too nascent. There's definitely some good stuff in there, but maybe the most valuable thing that I've seen come out of the data mesh conversation is actually the conversation itself. It's so if you think about software engineering, we have spent so much time, analyzing the way that we build code, the relationship between different modules, the differences between approaches of functional programming or, imperative programming or object orientation. There's like a wealth of different of sources of material out there. We've just really, as an industry, thought really hard about that problem. And I just feel that we haven't done anywhere near as much thinking or sort of experimentation on the data side of things. I think that's actually much more nascent. So this is it's probably the first thing that I've seen that really challenges the standard data warehouse architecture and the organizational constructs that come up around that. And even though we've known for many years it has problems, I mean, sort of the data lake thing had tried to have a go at it, but that was maybe not that productive. It kind of worked. So for me, a big part of it is actually the conversation and the thinking. There's a lot of people thinking about this and trying to work out better ways to do it, better ways to tackle the problem. And I think it's a big unsolved problem in our industry. So I very much welcome that conversation. That's one of the best bits, I think.
Well, data, the final frontier.
Yeah, that's one way to put it.
Cool. Ben, thank you very much for your time. Thanks for talking to us today.
Yeah, great to see you, Chris.
And no doubt we'll have you on the show again.
I
see you
so,
around.
yeah, lovely to be here.
Well, that was data mesh. There's a lot to think about there, and clearly some undiscovered country to explore. We'll have links to the blog post and the demo that Ben mentioned in the show notes if you want to start exploring. Before we go, let me remind you that if you want to learn more about event-driven architectures, we'll teach you everything we know at Confluent Developer. That's developer.confluent.io. If you're a beginner, we have getting started guides, and if you're more advanced, there are blog posts, recipes, in-depth courses, architectural patterns, all sorts. If you take one of our courses, you can follow along easily by setting up a Confluent Cloud account. And if you do that, make sure you register with the code podcast100, and we'll give you $100 of extra free credit. If you liked today's episode, then please give it a like or a star or a share or whatever buttons you have on that user interface, and let us know you care. And if you have a comment or want to get in touch, please do. If you're listening, you'll find our contact details in the show notes, and if you're watching, there are links in the description and probably a comment box just down there. With that, it just remains for me to thank Ben Stopford for joining us and you for listening. I've been your host, Chris Jenkins. Catch you next time.